Good morning, everyone. My name is Tingting. Today I'm sharing my individual assignment about environmental pollution. The presentation is divided into four parts. The first part is subject, and the second part is paper analysis, and the third part is comparison. The last part is conclusion. Okay, let's start part one. Subject. In part one subject, we talk about environmental pollution. In sustainable development, environmental issue has always been a significant factor blocking in the entire world. Environmental problems are constantly being addressed, but they also keep emerging. So environmental problems need to be solved urgently. Let's take a look at the distribution of environmental research in China as estimated in 2023. The research on environmental issues can be roughly divided into 6 types. Research types are mostly concentrated on water pollution through the waste treatment and air pollution. Among these, water and waste pollution account for the largest proportions, indicating the severity and urgency of two problems. Refer to the data of environmental problems in China. Water pollution and waste pollution account for a large proportions, indicating that these two types of problems are the most serious. Therefore, I set out to conduct research on such problems. The second part is analysis. I focused on 3 case studies across the different types of pollution. The first is groundwater pollution in industrial use, and the second, illegal landfill contamination in Japan. 3 is pesticide residue in agricultural regions of Pakistan. These studies use different quantitative research methods, which I will explain in following slides. The first paper investigating groundwater quality near an industrial zoo in Pakistan. The paper's objectives. The first is analyze the physical and chemical and environmental characteristics of groundwater samples. Second is assess the impact of industrial influence. The last object is recommend remedy and mitigation strategies. Researchers collected 6 groundwater samples at depths of 75 to 80 meters from different routes. They analyzed the physical and chemical properties, including some chemical elements and environmental such as chromiums, cadmiums, and the nickel. Leverage techniques used include chromatograph and atomic absorption spectrometry. This paper finding is about the 3 factors. The first is elevated levels of some chemical element near the chemical industry and high concentrations near the two industrial use. The last is industrial influence identified as the primary source of contamination. The second study focused on illegal landfill in Japan contaminated with 1,4 dioxide. This chemical is highly water soluble and very different to remote. This paper's object is to improve the feasibility of predicting pollutant transport in a conflicted hydrologic environment at illegal dropping site. And second, inverting is the characteristic of one and four dioxide transport under both nature and artificially induced groundwater flow. In this paper, Messer and data study arrived in legal industrial dumping city in Tohoku, Japan. Contaminant 1 and 4 dioxide, highly water-soluble, negligible degradation, adsorption, data monitoring role, GIS and SATA service. We can see important data from this picture. This model is numerical modeling, process underground water and through transport simulation. Simulated real-world interventions, equation, impermeable walls, popping walls, remediation, passive, natural attention, active, pop and treat using popping walls. This model is lasting from 2020 to 2060. It's about 40 years. This situation will be better. So that evidence this model is successful. This study demonstrates the power of predictive modeling in real-world environmental planning. So in this study, the finding is about the simulation reproduced the observed trend in 1 and 4 dioxide concentrations in monitoring walls supporting its predictive value. Passive treatment shows slow generation with lagging pollution near the impermeable wall. The most important is active treatment led to significant reduction, nearly eliminating pollution in 13 years. Attention, popping may catch a broader dispersion of pollutant due to dynamics flow. The third paper is pesticide residues in intensive agricultural soil and water bodies in Pakistan. In this study, we can see objective is 2 points. 1 point assess the species autopro distribution patterns of 21st pesticide residues in soil and water samples across 3 major agricultural hills. And the second part is feature investigates the physical-chemical factors influencing pesticide mobility and persistence. About its method and data, sampling set that is site 21 soil and 21 water samples from 3 tissues, and sample seasons is spring, summer, and autumn. And we can see analytics and analysis technique is measure the variables. The two picture is about data for this paper. Analysis of variance. One way, a ANOVA was used to determine whether there was significant differences in pesticide levels and physical-chemical parameters across different states and distances. It helps compare the residues variances across regions and seasons. Collection analysis. Pearson collaboration analysis and heat map visualization were applied to examine the relationships between water quality parameters and pesticide residue levels. Example, in summer, pesticide retention in soil had a strong positive correlation with organic matter, as well as with soil pH and ecosystem. This picture uses single and multiple linear regression models to analyze the relationship between pesticide concentrations in soil and water at different time points and their physical chemical properties. These models were used to apply correlations between pesticide residues and environmental factors such as pH, organic matter, calcium carbonate, nitrate, and sulfate. Pesticide contamination shows clean, seasonal, and spatial variations with higher levels in summer due to increased farming, irrigation, and climatic conditions. Concentrations often exceed regulatory limits with persistent pesticides like chlorpyrifos, azoxystrobin, and ozone-dentate. Saccharin region has the highest contamination, followed by Dor and New Lapshan. Okay, let's start three part. That is the comparison. Let's briefly compare the three papers. The first paper is descriptive and observational, focus on current groundwater contamination. The second used predictive physics-based numerical modeling for contaminated transport and remediation. The third paper integrates field monitoring with statistical modeling to assess seasonal and spatial pesticide trees. Paper 1 relied on sample-based lab testing. Paper 2 used time series simulation and numerical physics models. Paper 3 applied correlation analysis and regression models across time and space. The diversity shows how quantitative tools are tailored to specific research goals. Okay, the last part is the conclusion. In this part, we can see four conclusions. The first is the integration of multiple methods is the future trend. The trinity of experimental statistics and modeling enhances the persuasiveness of research. And then the second, research on environmental pollution should combine the spatial and temporal dimensions to avoid one-sided conclusions. The third conclusion is the explanatory power of data is more important than the volume of data. Reasonable modeling and analysis can mine the maximum value of limited data. The last conclusion, the application of research should take into account both the practical management and the policy recommendations, and not only pursue theoretical value. Thank you for your time and attention. This presentation dismounted how different quantitative methods can be applied to tackle environmental issues. I hope it has inspired you to see the power of combining data and environmental science. So together for sustainable development. I would be happy to answer any questions. Thank you again.